Good day and welcome to the Math Salon. I'm Dr. Anamandem. We are going to look at an advanced level question on trigonometry and solutions of equations, and also to be able to look at for the range of values which satisfy a certain relationship between trigonometric functions. So the first question says, find the general solution of the equation sine 2 alpha is equal to sine alpha. The second says, express cos x plus 2 sine x in the form Rcos into brackets x minus gamma, where R here is a positive number and gamma is an acute angle between 0 and 90 degrees. And then this one's the last one, says show that cos x plus 2 sine x lies between minus root 5 and root 5. So the minimum value is minus root 5 and the maximum value is root 5. So we start with the first one there. So the first one we expect to look for the general solution of sine 2 alpha is equal to sine alpha. This is just to remind you about how to get the general solution of trigonometric function. For the sine, we know the sine is positive in the first and the second quadrant. So it means here, if we look at this, the 2 alpha would be equal to 2 pi k. Because sine is a periodic function with a period of 2 pi, it means that if you keep on drawing sine, it comes and repeats the number after 2 pi times. So if you have an angle that's a general angle that keeps on behaving this way, then it will always have a jump, a space of 2 pi k. And then plus our angle, the alpha. Or if the alpha is in the second quadrant, then you know the angles are expressed there as pi minus alpha. So if I just draw, like say, if this is my alpha here, and this guy moves to this side here, then actually this is the angle you should be looking for. But then that is just like 180 minus this one. So that's the idea. So my gamma, which is the new one, is 180 for everything minus this small one. That's how we also express that another solution would be 2 pi k plus pi minus alpha. So if that is the case here, it means we can solve 2. So here, 2 alpha is equal to, I can take alpha a bit to this side, then I'll just get minus alpha is equal to 2 pi k. So 2 alpha minus alpha is equal to 2 pi k. Or if I solve it that way, then I have again my 2 alpha there is equal to 2 pi k plus pi minus alpha. If I take minus alpha to this side, it becomes plus alpha. So I get 3 alpha is equal to 2 pi k plus pi. You can divide all through by 3, then alpha is equal to 2/3 pi k plus pi on 3. So that's the general solution for this equation here. If it was cosine, you would remember that cosine is positive in the first and fourth quadrant. So it's going to be plus alpha or minus alpha. The angles in the fourth quadrant are expressed as minus alpha. So for the second one there, it says express our cos x plus 2 sine x as something r cos x minus gamma. I think we did something like this similar in some videos long time ago, but then it was a cos here. So this is another skill you can also put in your toolbox for the exam. If this is the case, what we normally do is the simplest way is to expand this and then equate terms. So if we do that here, if I open this up, you have to remember the relationship between cos of two functions there. And I said sometimes you'll be able to do that in a formula booklet, but the cosine of, for example, a minus b is given as the cosine of a, the cosine, just write it down here. Let's go to the cosine of a, cosine of b, plus sine of a, sine of b. That you should have already seen in the past. And if it is a plus here, then we are going to have a minus here. Cos is always together with cos and does not mix with sine. But if it was sine, there's always a mix. Just something to keep at the back of your mind. If that is the case here, then it means I will say this is r, the cosine of x, the cosine of gamma, plus r, the sine of x, the sine of gamma. If this is true here, gamma is a constant. It's an angle. So this and this are constants. So to write it neatly, I would say this is r cos sine of gamma cosine of x plus r sine of gamma sine of x. So that if these two are identical, then we can equate the coefficients in front of each of these variables here, the functions here. So here this is 1, and that should be equal to r cos gamma. So 1 is equal to r cosine of gamma. And here this is 2. That should match with r sine gamma. So 2 is equal to r sine of gamma. With these two equations, we are able to solve for r by using the fundamental trigonometric identity. So what we do is, if I call this equation 1, equation 2, if I square equation 1, I get 1 is equal to r squared cosine of squared gamma. And if I square equation 2, I get 4 is equal to r squared sine squared of gamma. If I sum these two, then I'm going to get 1 plus 4, which is 5. So we'll just do that. Let's just do sum. That's 5. And that should be equal to r squared cosine squared gamma plus r squared sine squared gamma. But r squared is the same here, so I can factorize. And I can put it outside as r squared into brackets. I remain with cosine squared gamma plus sine squared gamma. But from the trigonometric identity, we know the fundamental one, this is 1. So it means that my 5 is equal to r squared. So r is equal to the square root of 5. R is positive, so I don't take the minus 1. Also, r is positive. So we are left now to look for gamma. If I divide equation 1 on 2, so 2 divided by 1 would mean 2 divided by 1, that is 2. 2 on 1, which is equal to r sine gamma all over r cos gamma. I want just to get the tangent. Otherwise, you have to play much more. So if this is true, then the r's go off, and 2 is equal to the tangent of gamma here. So if you do this, you will say that your gamma is equal to the tangent inverse of 2. This should be approximately 60 degrees. Normally it's like 63 point something, but for neatness, I would just say approximately 60 degrees. In the exam, you can use a calculator. So it means I can express this approximately as root of 5, the cosine of x minus 60 degrees. This is just an approximate, so this is not 60, it should be 63 point something. I'm able to express that. So for the third part of the question, it says, show that this lies in that range. Of course, I see that this is exactly this, and if I was able to express it into this form, then I can also borrow the idea there. So we know that cosine of x plus 2 sine of x can be approximately written as square root of 5 cosine of x minus 60 degrees. So I can take this now and try to play with it. The cosine and the sine function have a minimum value minus 1 and a maximum value 1. So it means that this part, the cosine of x minus 60, is a cosine function. So it's always going to be less than 1, greater than or equal to minus 1. That will always be the case. But what I have here has root 5 on it. So in order to get root 5 here, I'll multiply all through by root 5. It's a positive value according to the arrow there. So the inequality sign will not change. So this is minus root 5 is less than or equal to root 5 cosine of x minus 60 degrees less than or equal to root 5. Of course, we just said this is identical to that approximately. So this is minus root 5 is less than or equal to, I can write that there, cos x plus 2 sine x less than or equal to root 5. Sometimes this question is also asked in the form, what is the maximum value, what is the minimum value, and so on. So you should be able to know. Here, this is the maximum value, root 5, the minimum value minus root 5. If you were asked to look for the maximum value of 1 divided by that, then you have to know that they reciprocate. So if the function, which is a reciprocal of another function, is maximum, that means that the function that is the denominator has to be minimum, and vice versa. Okay, hope you liked it. If you did, please remember to give us some thumbs up, subscribe, and if there's something you missed, leave me a comment. Thank you.